Today we are talking about preserving climate data with the National Weather Service. So that is what our database collection will be about. First, we're going to introduce the collection. The National Weather Service is concerned about the future of climate data. So they are beginning a project to collect and preserve climate change data into a digital archive. And so this is going to be accessible to the public, but it will also be a primary source for scientists who are needing to look at atmosphere and climate information for their own specific research. And we're going to focus the data on North American institutes just because of the proximity to that climate and the urgency of that section of the globe from the National Weather Service's standpoint and where that is located, but it will also accept information from international climate agencies all over the world because of the interaction of climate and because that is all interchangeable throughout the globe. So a little bit more detail about the collection. We are primarily looking for raw data, and that is because climate data, a lot of times, not all the time, but a lot of times, is very self-explanatory. For instance, measurements such as temperature measurements and levels of ocean or sizes of glaciers, um, the drawback of water from the shore, evaporation rates, a lot of those are very self-explanatory even with just the numbers that you have. So we are looking for raw data as to keep the collection apolitical and to keep any sort of bias from the user or collector from leaking into the information that we have. And we're going to accept any medium, but we are expecting mostly text documents or electronic copies of those text documents. And so the metadata will be able to handle any sort of medium, such as video or photos or graphics, but we are expecting mostly text documents, and any physical documents that we have will be scanned to become electronic copies for easy storage and access. Our use needs for this collection, the primary use is going to be from the National Weather Service itself. That is because of proximity to the collection. It is also going to be open to the general public to search and browse, and those general public members can also include academic people from other institutions in the United States or wherever want to access this. We're expecting a lot of that type of information need. However, it will also be for the general non-academic public, whoever wants to use it, and therefore that has informed us of the kind of content management system that we want to use so that it will be publicly accessible without needing a professional or university login to access this information. So the metadata schema that we chose was the Climate and Forecast Metadata Conventions, and that is because the Climate and Forecast Metadata Conventions are both the easiest to understand and the most flexible conventions for this specific type of data. And the Climate and Forecast Metadata Conventions, they get very detailed about the types of data that we're going to use, but they are also very clear. So again, take for instance temperature measurements. That is a specific label on the Climate and Forecast Metadata Conventions, and that is what it is called. It is called temperature measurements, and so there is no question as to what that means, and it's also very specific to that data. And so the Climate and Forecast Metadata Conventions are also compatible with a good many of the scientific metadata schema, and also with general metadata schema and with systems such as XML that will allow it to be very much meshed into the different systems and go well with other scientific data. So we did consider a couple other metadata schema, such as the Common Information Model, several scientific data models, and also something called Data Package, which is also specifically for biological sciences. But these were all rejected because either they had specific conventions that were required for each piece of data that would not fit climate data. The standards were not accessible for both scientists and the general public. Usually they were too scientific to be clear to the general public what they were talking about, or the standards did not support raw data, which, as I mentioned, is a big part of this collection. So our controlled vocabulary choice was also pretty easy to get. That needed to be thorough without being intimidating to the non-scientific public, which again, that is a big thing for us for this collection. And so the Climate and Forecast Metadata Conventions actually has its own controlled vocabulary called the Climate and Forecast Standard, which is great because that is automatically built into that metadata schema that we chose. So it covers objective, quantitative, and time and space measurements, and again, those are self-explanatory. So if I could give you an example of that, so one type of standard would be flood water speed. Now that is very straightforward. How fast was water going during the flood? And that is also a very important measurement. And so there's also things like fire temperature, forecast reference time, etc. And these are very important to both the data and to understanding the data. And so this vocabulary also does what a lot of scientific vocabularies do, and it reduces data duplication. So it's very consciously not repeating data throughout the metadata scheme, which is great, and it allows for basic discovery data as part of controlled vocabulary, which is just another way to say that general public does not have to know specific scientific terms to search and find something meaningful with the search terms that they can think of themselves, such as temperature. And another and very important part of this is this controlled vocabulary choice ensures formal recognition from the scientific community, and that is very important for all of this to mesh together with the rest of the scientific community. And our content management system choice was very influenced by the need to be simple, manageable, and open to the public without login barriers. Simple to manage was also important because the upkeep of this will primarily be for scientific-minded people. Ideally, the National Weather Service would get an information scientist or library professional to help them with this, but we want the content management system to be easy enough to understand so that if they do not have access to that sort of expertise, they can manage it themselves with minimal issues. And the open access movement has made giant strides in the past few years with the professional level of its products. And so we chose the Advanced Tracking and Resource Tool for Archive Collections, and that is a product of the open access movement in science. And fortunately, science has been pretty much the first one on the bandwagon for the open access tools to share research, which is exactly what we need. And so the Advanced Tracking and Resource Tool for Archive Collections is a website, a database website hosted by the National Centers for Environmental Information. And so what that does is they take whichever organization they would like. They take whichever organization would like to use part of their database, and they give them each a section on the website. So each organization has its own project section, and so therefore the National Weather Service information will be in proximity to information that is like it and is very related to it and can put its own information into context, but it is also separate from the other information and can be searched on its own and hosted on its own as well. So its usage has to be approved by the NCEA, but we don't anticipate problems with that because the data conforms to the standards of the National Oceanic and Atmospheric Administration, and they are already a member of the Advanced Tracking and Resource Tool for Archive Collection. So the National Weather Service information uses the same standards that NOAA does, so there shouldn't be any issue getting into this open access system. So the one thing is there will need to be periodic monitoring by the National Weather Service, because the NCEI will be in charge of the data upkeep. So the National Weather Service needs to check in and make sure that everything is going as planned periodically. So the future of this data ties in with the future of climate information in North America. The priority of this collection is preserving climate data. That is the most important for us in this collection. It's designed to fill current and anticipated information gaps in this area of scientific data, and the National Weather Service should guard against it or the service itself becoming politicized, so the data does not start to slant one way or the other. The National Weather Service should also have a secondary agency ready to take over these duties in case of emergency, and we are recommending that the National Oceanic and Atmospheric Agency do that, since both of these services are very closely entwined with each other's purposes. So this information is vital to our present and our future on Earth, and so that is why we are so concerned and so ready to make this climate change metadata system for everybody to access and remember what we need to